So for the first question, Janice and Talon aren't sure of cupcakes they want to make yet or how much baking powder they will need. Represent the relationship between number of tablespoons of baking powder, highlight that, and the number of cupcakes the recipe makes, number of cupcakes, as equivalent ratios on the graph and table. Well, before I start the problem, I want to find a couple things. I need to find the baking powder. So I look through the recipe and I find 1.5 teaspoons of baking powder. Makes me how many cupcakes? If I look at the top, makes me 60 cupcakes. Okay, so that's important, first off. Second, I want to look at the table to my right. I have my teaspoons of baking powder and my number of cupcakes, and it's already put into the table for me. If we know about an XY table, X comes first, and Y comes second. So now, when I go to label my graph, I already know that on the Y-axis I'm going to put cupcakes on the Y-axis. And I'm going to put teaspoons on the X-axis. This way I know that when I go to take my information from the table to the graph, I know what goes on which axis. So if I look at the recipe, it says 1.5 teaspoons of baking powder makes 60 cupcakes. So there are a couple ways you can do the table. I personally like to take the information given in the table and just use that right away. So if I look, I know that 1.5 makes 60. Now let's say I wanted to make a double recipe. I could just take my 1.5, or 3/2, and double it. Three halves times 2/1 would give me 6/2, which is 3. So then if I double the teaspoons, I'm going to have 3 teaspoons, and then doubling 60 is 120. Now I notice a pattern. I notice that each box in the chart will go up by 1.5 for the teaspoons. So I can go 4.5, and then 6, and then 180, 240. So that's one of the correct ways that I can fill out the table. Another way we can do the table, because if we look at later parts of the problem, it's going to ask us for the unit rate. So we can find the unit rate of how many cupcakes per 1 teaspoon. So if it's cupcakes per teaspoon, I want to take 60 cupcakes and divide it by 1.5. So 60 divided by 1.5, or 60 divided by 1.5. Or you can turn these into fractions and keep change flip. But I would get 40 cupcakes for 1 teaspoon. And that's really important for later. 40 cupcakes per 1 teaspoon. Now I know how much 1 teaspoon gives me 40. Now I can continue to use the unit rate and fill out the table. So for 2, I would just double, go to 80. And then on the left side, I can add 1 each time, increase, and then I'm adding 40 each time. We know that this table is a proportional relationship. So there are multiple ways that you can fill out the table. So as long as your table is consistent with a k value for when you do y divided by x and you get 40, which is our unit rate, your table should be fine. I'm going to stick with this table because now it's going to be super easy to fill out our graph. I'm going to clear up some space here. I've already labeled my graph. I have teaspoons on the bottom and I have cupcakes on the top, on the y-axis. When I go to fill in the graph, I need to make sure that I'm giving accurate and equal spacing on my scales. So if my X scale is by ones, 1, 2, 3, 4, I either want to go one box at a time or I can go two boxes at a time. For this case, to keep it simple, I'm going to go 1, 2, 3, 4. And for my cupcakes, I'm going to keep that same scale, just going one box at a time, 40. Because if I do an unbalanced scale, my line is not going to look straight, and even though the points would be correct, the scale is going to be off, and it's not going to look proportional. Once I've filled in my sides, 1, 40, I can put the points in. And I know that for a graph to be a proportional relationship, I need it to be a straight line, and I also need to make sure that it's starting at the origin, because 0 teaspoons is going to give me 0 cupcakes. I draw my line. Make sure your line goes all the way to the end with a little arrow, because this graph could represent any amount of teaspoons. And there's our graph, and there's our table.